Welcome back, I'm Christopher and it's now time to talk about the proxy design pattern. If you're not already familiar with this playlist or channel, what we're doing is that we're walking through all of the patterns in this book. Head first, design patterns. And as you know, if you've watched the previous videos, I highly recommend that you get this book if you're new to design patterns. The link is in the description. It's a super pedagogical book. If you're not new to design patterns, I'd recommend that you get this book instead by Gang of Four. So this is like the classic de facto design patterns book, the original. And if you decide to get both, I wouldn't say that it's a waste of money. Good spend, put them on your shelf, keep them as a reference. Whenever you're wondering about design patterns, go back to the source. We have all these resources on the internet, right? But when I find conflicting information, I tend to go back to this book and say, okay, what was the original intent of that pattern? So, super good book to keep. Now let's move on. So what is the proxy pattern? Let's simply start off with the definition from this book. So in the head first book, we get this information. The proxy pattern provides a surrogate or placeholder for another object to control access to it. Again, so the proxy pattern provides a surrogate or placeholder for another object in order to control access to it. So this is just a way of saying that you have an object that you want to get access to, that you want to invoke methods on, that you want to somehow interact with. But instead of being allowed to interact with that thing, you interact with a proxy who interacts with that thing. So it's another way of introducing another level of indirection. Instead of calling the thing you want to call, you call a thing that calls the thing you want. And if you watch the previous videos, you know that we'll do a specific video after this one on the differences between decorator, adapter, facade, and proxy, because they're sort of kind of alike. So I won't dig in too much into specific differences between this and the other patterns right now. But just think about it this way. It's not only about how you string the objects together, it's also about the intent. Like, some patterns are mostly different in intent rather than in the technicalities. So they might be doing on the surface, or technically, like concretely, they might be doing exactly the same thing, but what's different is that you are doing it for a different reason. So you might use the word proxy to communicate to other developers what kind of problem you're trying to solve, and then you might use another word to communicate to other developers that you're trying to solve a different kind of problem. And a proxy, with proxies, we're trying to solve a specific set of problems that are all access related. So you put a proxy in front of something that you want to allow people to access, but you have the proxy so that you can control access to that thing. And in this book, Head First, and in this book, Design Patterns, they talk about 3 versions of proxy pattern, or I shouldn't say versions, I should say styles, or maybe intents, or ways that the proxy pattern is used to control access. These 3 ways are called 3 different things. So they say that a proxy can either be a remote proxy, a virtual proxy, or a protection proxy. Let's write these down. So you've got a remote proxy, a virtual proxy, and a protection proxy. Now, a remote proxy is suggested to be used when you want to access a resource that's remote. What do we mean with remote here? We mean something that could exist on, for example, a different server, or in a completely different namespace, in a different code project. So somehow you have to leave like the safe boundary of your application out into the outside world in order to retrieve some information back. And so this interaction, this sort of transaction could be wrapped in a proxy. So your proxy is responsible for this interaction, or is responsible for interacting with the remote resource and giving you back the things that you need. If you're familiar with the concept of promises that are now commonly used in Node.js, I like to think of it as in like that the proxy is something that would interact with a remote resource but immediately return you a promise. So it returns you a promise that promises to evaluate to the concrete resource that you were looking for after a while. But instead of scattering this HTTP request or socket connection or whatever it is across your application, you have this proxy that simply interacts with this remote resource on your behalf. So I should mention that one of the key things of the proxy pattern is that the proxy pattern looks like the remote resource. The proxy pattern looks like the thing it's proxying. So if you think about adapter pattern, for example, adapter pattern adapts to a different interface. Adapter pattern lets you say that you want to access a thing that has some particular interface, but you have a different interface and you want to access it via your different interface. Proxy pattern, however, is simply a way of controlling the access, so it doesn't change the interface. So you have something that you want to interact with that has some particular interface, and you don't want to change the interface. You simply want to intercept the accessing of that thing that you want to access for some reason, such as security or caching or the kind of stuff that we're getting into here. It's a little bit hairy, and if I'm completely honest, I'm slightly confused by this myself. So if you want us to dig further into this, do ping, and then I'll dig more, and then we'll talk about it some more. This book has some super concrete examples that are from Java. I haven't actually used the specific technologies that they talk about, so this is why I'm not diving into that. But if you're interested in that, I highly suggest that you get this book. And again, if you want us to dig deeper into this, do shoot something in the comments and then we'll talk about it. Moving on. Next one, virtual proxy. A virtual proxy controls access to a resource that is expensive to create. A virtual proxy controls access to a resource that is expensive to create. So this is like caching, right? We'll talk about this one more specifically. So we got these three, right? And the example I want to take is from virtual proxy. So we'll dig more into that in just a moment. But just think about it. Right? It controls access to a resource that is expensive to create. So you got some object which you want to interact with, but you know that creating that object is expensive. So you put something in front that you can interact with instead. And then that thing, that proxy, makes sure that only when you really, really need it do you interact with the actual underlying thing. So it's kind of like lazy evaluation. Third one, a protection proxy. A protection proxy you can think about as access management. So you've got a user and you're not sure whether a particular user has the rights to access a particular resource. So you stick this protection proxy in between, and that protection proxy makes sure that only users that are allowed to access the underlying resource do get access to the underlying resource. But this is of course just one example. On the general plane, the point is that it controls access to a resource based on access rights. So you make a call to some underlying thing, and the question is, are you allowed to, at that point, make that particular call? The proxy makes sure that if you aren't allowed to make that call, you can't make that call. And if you are allowed to make that call, you can make that call. So those are the three. I want to spend a bit more time talking about the virtual proxy, so we won't dig into the other ones, but hopefully you can see how what the proxy pattern does is that it adds some additional behavior, not in the sense of decorator pattern, but in the sense that it adds additional behavior with the intent of controlling access to the underlying object. So both proxy and decorator adds additional behavior, but decorator is much more general and is designed so that you can sort of stack decorators, where you decorate a thing that's decorated by a decorator, that's decorated by a decorator, and so forth and so forth. Whereas proxy pattern simply says that for some reason you need to control access to some underlying object, and because of that you need to add additional behavior. But you don't want to change the interface. You want to interact with the thing in the same way you've always interacted with it, as if it was the real thing, but you want to add some additional behavior just before you make calls to it. So let's get into a virtual proxy example. So let's get rid of this stuff. And here's the example. Imagine that you've got a string called book that contains a whole book represented as a string. I'll just put ... here, but imagine that this string is massive, like it's huge, right? So this is a string representation of a book in like XML format or HTML format or Markdown or restructured text or whatever. I mean, some arbitrary format. It doesn't matter for the sake of this example. The point is that the string is huge. Then let's say that we've already written a class. Let's call it the book parser. So let's say that we have a class called book parser that we can instantiate. So we can say book parser, just say BP to save space, equals a new book parser. And then to the constructor, we simply pass this book string, right? So this is the string containing the whole massive book, right? Just think about it. I mean, this book or this book, I mean, they're quite thick, right? So there's sort of a lot of contents in that string. You could even, to make the example worse, I mean, just imagine like the thickest book you can possibly think of. So we've got this string representation of book, we pass it to the book parser. Why do we do this? Because in this application, we can then take this BP instance and say BP dot something like number of pages, or BP dot number of chapters, or BP dot number of adverbs. I'm just introducing some random stuff, right? I'm just trying to say that the book parser, for some reason, we have some application, right? For some reason we want to do this. The book parser, when you construct it, will immediately parse the book and then give you a few methods that expose the result of this parsing. So what this parsing does is that it pre-calculates a bunch of different things, such as the number of pages, the number of chapters, the number of words, the number of verbs, the number of adverbs, the number of nouns, the complexity level of the text, a bunch of different things, right? So like imagine that there are so many things that this computation is actually pretty intense, because like the book is thick, and even if it's just a string, the string is like so long that if you need to do all of this calculation, there's actually a lot of calculation that you have to do. Now, as an interesting side point, you might interject and say, but if you say that this book parser pre-computes the value of these different things, why don't you make these accessors? Why don't you make them public fields with private setters and public getters, so that the book parser does the parsing and then sets these values? Because then it would really indicate to other developers that this field does not entail computation. It will instantly give you the value because it's not a method, right? Like you would invoke it. You would not invoke it, you would simply access the member. I'm struggling to remember what the quote is and where the quote comes from, but if you do remember, please shoot that in the comments so we can sort of dig down this source. But I'm fairly sure that somebody said that properties and methods should be accessed in the same way, or not necessarily like that, but that from the outside it should not be obvious whether you are accessing a field or a method. Like if you invoke a method on an object without passing it arguments, you shouldn't know whether that's invoking a method or accessing a field. Because if you first make it a field and then want to change your mind later to make it a method, then that shouldn't cause you compilation problems. Like it shouldn't cause you syntactical problems. You shouldn't have to, if you decide to change from a field to a method, that shouldn't mean that you have to change the things that access the method or the field. That should only mean that you have to change the one exposing the field. I may be completely wrong here, but I think this is one of the reasons that people argue that it's a good thing that in the language Ruby, for example, you can't tell whether you're accessing a property or you're accessing a method. It has the same syntax. So this is the reason why I did this. Like, I tend to, in always, essentially, make use of methods, because you never know when you want to change your mind in the future, and it's not like there's a huge overhead to making it a method. But that's enough from that sidetrack, let's move on. By the way, if you disagree, please do absolutely shoot that in the comments so we can have a discussion. Moving on. So, we know that invoking these methods is cheap because the cost has already been incurred. Because this statement is, in this particular application, not cheap. Remember that it's just a purely hypothetical example, and this would completely depend on what you're building, right? But we're just imagining a scenario where this is not cheap, but this is cheap. Now, the point is this. For some other absurd reason, we happen to, in our application, instantiate book parsers, even though sometimes we never actually call these methods. And for some even other absurd reason, we don't want to change that behavior. So I'm putting up this sort of very arbitrary scenario where, like, we don't want to change the contents of the book parser, we don't want to change the way this behaves, and we don't want to change the fact that we have to instantiate a lot of book parsers because for some reason we need to pass them around. Like, let's say that for some other reason we've made some other architectural decisions that means that we need to instantiate book parsers and pass them around, even though sometimes we won't actually call any of these methods. Now, of course, this is a purely hypothetical example, so please try to forgive me for the contrivedness. Probably the rational solution in this scenario, would actually be to refactor the book parser and make it lazy. Make it so that the cost is incurred here instead of here. Like, I would probably say that that's the better way to do it. But you could think of it this way. Maybe the book parser is an external library. Maybe we didn't actually write the book parser. Again, like, there could be a multitude of different reasons for why we don't want to change the book parser. But let's move on. I hope you buy into that scenario. So, another way of solving this problem would be using Proxy Pattern. So I haven't really said why it's a problem yet. Let's say that the problem appears now in that perhaps you've heard the phrase premature optimization. So premature optimization suggests that you should not start to increase the performance of your application or attempt to increase the performance of your application before you know that you actually have a performance problem. In other words, don't spend time trying to make your app perform better in terms of how fast it executes, don't try to do that before you actually know that you have a problem with it, right? Because I guess this statement stems a lot from how some people tend to, like, let's say you're doing code review and you get to review a piece of code and then you add a comment to that code and you say, well, couldn't we perhaps refactor this so that it's a bit more understandable? And then the author of the code says, but hey, you can't refactor it that way because that way would be significantly slower. This is the super performant way. And then they're just shoveling bits around. There are so many ways to do things so much faster, but there's always that tension, right? Like, the more readable a program is, the less performant it tends to be. And the more performant you make it, the less readable it tends to get, purely informally. But like, it kind of makes sense, right? Because like, we're using higher abstraction building blocks when we write programs that are easy to understand, or let's say, well, I guess abstract in their nature, like they are discussable on a higher plane, which we tend to call readable code. But if you want something that's performant, you have to write code that's understandable for the computer, but not necessarily understandable for a human. So back to the point, what we were saying is that, let's say that we wrote this code when we didn't know that we had a performance problem. But now suddenly we realized, oof, we have a performance problem. We need to, for some reason, increase the performance of the application. And this we see as one opportunity. So how do we do this? What we can do is that we can stick a proxy in between whoever calls the book parser, or whoever calls these methods on the book parser. So let's say that, as usual, we have like a client. As usual, we mean client as in some particular piece of code that uses some other particular piece of code, not like a customer. And this client, let's say, used to use the book parser. I'll just put BP to represent the book parser. Let's say that it first instantiated it. So let's say that first it instantiates it. I'll just write new here. And then it will call one of these methods. I'll just write call here to emphasize that it calls one of these methods. And we know that this first method call is the expensive one, and the second one is the cheap one. And we also know that we won't always call this cheap method. We won't always call the second method. So the hypothesis of how we can improve performance, or like the idea of how we can improve performance in this scenario, is that we want to say that constructing, doing this expensive operation, should only happen if you actually want to call a method. So we want to defer. We want to make it lazy. And that's why we want to stick a proxy in between. So what we do, instead of doing that, is that we simply say, you've got the client, but instead of the client directly interacting with the book parser, we interact with the proxy. The client interacts with the proxy, who interacts with the book parser. So the client instantiates a proxy. The proxy doesn't instantiate a book parser, because the proxy says, okay, hang on, I don't know whether you actually will call any of the methods that requires me to parse this book. So I'll wait until you tell me that I need to parse because you want some of this information. So the proxy will simply stop here, right? The client will have a proxy, and that proxy will follow the same interface as the book parser. So that's back to the idea that the proxy has the same interface as the one it's proxying. So the client can keep behaving, can keep passing around this proxy as if it was a book parser, in the same way that it's always done. But now we are deferring the instantiation of the underlying book parser. So let's talk about the call here. So let's say now that the client wants to make this call. So it could be it wants to ask for the number of pages. So instead then of making the call directly to the book parser, it makes the call to the thing that it thinks is a book parser, which is this proxy. So it makes this call. I should have written new here to say that the top line is new, it's instantiation, and then the second one is call. And then we're calling one of these methods. And then when it does that call, of course this call is super cheap because it's just to the proxy, but then the proxy says, you now actually want some of this information, which requires me to actually do the parsing. So then the proxy will simply do this call. It will simply instantiate the book parser and thus incur the cost of that computation, or actually have to do that computation, the expensive computation. And that's when we'll get the performance hit. And then immediately after that, make the call, which is of course then cheap, and then pass the object backwards to the client where it was making that call. Then of course you have to realize that we have to construct a proxy that's smart enough to not rebuild book parsers every time we make a new call, because then obviously performance will probably be worse than in the first scenario. The proxy has to cache the book parser. So the proxy builds the book parser the first time and maintains the reference to that book parser, so that the second time we make a call to the same or another one of these methods, then we simply simply already have a book parser and can then simply just make that quick call to the book parser. Super important to remember that, I mean, this is a purely hypothetical example. So there are a multitude of other ways of doing caching and a multitude of other ways in which we could find ourselves in the need to do caching, and a multitude of other situations which we could find ourselves in that would require or suggest that we need caching. So the proxy pattern, as in the virtual proxy, the type of proxy that creates expensive objects on demand rather than immediately rather than pre-computing them, rather than creating them eagerly. That kind of proxy pattern could be applied in a number of different situations. This is just one hypothetical example. But okay, let's now look at the UML and let's discuss how it relates to what we just talked about. All right, so what do we got? We've got an interface called subject. And I'll just put an I in front so that it's named iSubject, just to denote that it's an interface. Just convention. This subject has some kind of method, which we'll just name request. Obviously, this could be anything, and in our previous example, this method, this represents the different methods that we had that were named something along the lines of get number of pages, get number of nouns, get number of adverbs, get number of whatever. Those methods, that's what we're trying to denote when we're saying request here. An interface that we will call subject. But because it is an interface, we'll precede it with an I. So we'll say iSubject just to denote that it's an interface, just by convention. This interface has some method or some set of methods, but we'll represent that here with just one method, which we call request. This method request, of course, depends on what your scenario is. In our previous example, this request method, this request would be one of the methods called get number of pages or get number of adverbs or get number of words or whatever methods we had. This simply represents that kind of call. We want to make some kind of call to this subject, and in order to have a method here, let's just call it request. Now, this subject needs to be implemented. This interface called iSubject needs to be implemented by something. So a concrete subject. In the Head First book, they call it the real subject rather than a concrete subject. If you've been watching the other videos, you know that most of the times when we have a realization of an interface, we've been calling it concrete something something. So like we had a decorator and then a concrete decorator, which would suggest that if we have an iSubject, we should have a concrete subject. I think the reason that they're saying real subject is to emphasize that this is the thing we had before we introduced the proxy, or this is the thing that contains the underlying actual thing we want to do, but then we stick a proxy in between. And the proxy will also be concrete. So we have two things that are concrete, and then that's probably the reason why they're saying real, just to make it easier for us to differentiate between the two, even though both are concrete. We'll name this concrete. Stupid me, now I named it concrete anyway. Let's just remove this. So we'll name it real subject. And that's a concretion. And of course, because it's a realization of this interface, we need to implement the method request. So in our previous example, this was the book parser. It's the book parser that follows a particular interface that could be an iBook parser, for example. As you might have guessed, the next step is that we'll introduce a proxy that would implement the interface iSubject. So let's now look at the final piece, the proxy. So we have another class, which is also a concretion, that we call a proxy. And of course, now we're just staying in the general world. I mean, this would be, again, like, depending on your scenario, you would name these sensibly. So maybe this is an iBook parser, this is a book parser, and this is like a lazy book parser proxy, or something like that. I would probably put the word lazy in just to emphasize that that's the problem that we're trying to solve, or that's the thing that we're adding on, and that's the reason why we're using this proxy. And of course, then this proxy implements this interface iSubject. As we were saying before, the proxy behaves as the subject, and that's how you get the substitutability. That's how you can exchange proxies for subjects, and vice versa. And finally, of course, the proxy also needs to implement the request method. And again, this request method could be multiple methods, and you would name them something which is sensible for your scenario. So in our scenario, this could have been, for example, get number of words. So this is get number of words, get number of words, and get number of words. Now, the final arrow that we're missing is, bada boom, this. The real subject implements the interface iSubject. The proxy implements the interface iSubject. But the proxy has a real subject. So the proxy is, not as in inheritance, but as in implements the interface, behaves as a subject, but it has a real subject, which means that it can delegate to the real subject. Which means that we can do the whole delaying the instantiation that we talked about before. So if you contrast this to the decorator pattern, when we were passing the thing decorated through the constructor of the decorator, that's not what we're doing here. You could do that if you wanted to. You could pass an instantiated real subject to a proxy, but that wouldn't help in our particular scenario. In our particular scenario, we want to say that the proxy is responsible for instantiating the real subject, because that instantiation is actually the expensive operation. That's actually the operation that we want to control access to. We're creating a proxy, and here is where we have the capability of controlling access. A proxy has a real subject, and because it has that, it is responsible for controlling the access. It is responsible for delegating whenever appropriate. So in completely other scenarios, it could do things such as whenever you call request the first time, you delegate the request to the real subject. But whenever you call it a second time or any time after the first time, you'll just get the value that the proxy saved for that request in itself, and thus it won't make an actual call to the real subject. So like caching. The proxy asks the real subject for the value the first time, but then assumes that the value will stay the same in the future. I mean, if you want to do something even more complex, you could have like you serialize the arguments that you pass to the request method and look if this request looks just like the other request, and then you check the cache or whatever. I mean, like caching is a difficult problem, right? I mean, there's a lot of different ways you could solve this, and depending on your scenario, you might need different solutions. But the general point is the proxy controls the access to the real subject. Point number one. And point number two, the proxy follows the same interface as the thing it is proxying. This proxy proxies the real subject, and the real subject implements the interface iSubject, which the proxy also does. So the proxy will be interchangeable for this real subject. It will be interchangeable for the thing it's proxying. Third point, the proxy doesn't necessarily have to be passed the real subject upon instantiation. It doesn't necessarily have to be past the thing it's going to proxy at instantiation. The proxy may, if you want to, if you need to, be responsible for instantiating the real subject. And in many scenarios, that is the sought for behavior. And that's it. You hopefully now feel that we've nailed the proxy pattern. If not, please do shoot something in the comments and we'll discuss further. Before we wrap up, let's super quickly look at some code. Let's get rid of this stuff. And let's build up some code for the example that we talked about before with the book parser. So, hypothetically, let's think about this. So we have a class called the book parser. The book parser. And it has a constructor, public book parser, that takes a string representing a book and does some super heavy computation upon that string. That's the tough part we wanted to avoid. So this is like, so I'll just put like a comment here that says expensive parsing, right? So obviously I won't write that implementation because it doesn't really matter, but you can just imagine that whenever we run this constructor, we have to perform lots of expensive computation. Now, then it has a bunch of methods. Let's just put one of them here. So let's say that we have a public method that returns, let's say, an int, and it's called getNumPages. Sorry, I'm just using the short name getNumPages instead of getNumberOfPages just to save space. And that method has some implementation that depends on this computation. So again, I'll put ... because it doesn't really matter what this actually does. Now, that's the book parser. Let's close out the book parser. We're missing one piece, and that is that the book parser needs to implement an interface. This is the concrete book parser, but actually the book parser needs to implement, so we'll say, colon to denote implements, iBook parser. And the iBook parser is an interface, so let's write that interface. So interface iBook parser. And that interface requires that whoever implements that interface implements this method, getNumPages. So we'll here specify getNumPages, a void method that takes no arguments. And that's the interface. Let me just put a line so that we can see that these are not the same thing. Let me put another line here for the next thing. So we have two pieces, and there's one piece missing. This is what in the UML was known as the iSubject. This is what was in the UML known as the real subject. And what we're missing is now the proxy. So let's write the proxy. The proxy is a class. I have no idea how I'm going to fit this. Let's try. Proxy is a class. Let's write class. So I'll name it lazy book parser. And let's just put proxy here as well to denote that we're proxying. We're proxying on behalf of a book parser. Let's open that up. And this class doesn't actually need a constructor. Of course, it needs a constructor, but we don't need the constructor to take any arguments. So in almost any language, we can ignore specifying the constructor because then we'll just default to having an empty constructor. The reason I'm saying that is that unlike in the case of the decorator pattern, for example, we're not required to support the sort of chaining of multiple decorators. So in this case, we don't necessarily have to support the sort of chaining of multiple proxies, like a proxy of a proxy of a proxy. You could have a proxy that's a proxy of a proxy of a proxy, right? It's completely allowed, but it's not inherent to the pattern. It's not required to be able to be considered a proxy pattern. So we don't need a constructor here. However, we need an instance variable because we want to keep track of whether we have instantiated the book parser or not. Again, it's lazy, so we only want to instantiate the book parser whenever we actually need to instantiate the book parser, the real subject, and not beforehand. So in order to keep track of that, we need an instance variable. And instead of setting that in the constructor, I'll just assume that this hypothetical language that we're using supports the following syntax. Let's just create an instance variable that defaults to null. So we'll have a private instance variable here, let's say private, and it is of type book parser, concrete book parser equals null. Why? Because we don't have a book parser yet. So if I would say new book parser here, that would mean that whenever we instantiate a lazy book parser proxy, we also instantiate a book parser, which means that we will necessarily have to incur this expensive computation. We will necessarily have to perform this expensive computation. That's not what we want, so instead we just set it to null as default. Then what? Because this lazy book parser proxy, oh sorry, I actually forgot. This lazy book parser proxy, of course, needs to implement the interface iBookParser. And because it implements the interface iBookParser, it needs to implement all of the methods. So we need to have a public method called, so sloppy, sorry, I forgot to, in the interface I should have said int here to denote that this getNumPages method should return an int, as it does here in the book parser. So that should be part of the interface, sorry. So we need here in the lazy book parser proxy a public method that returns an int and is called getNumPages and takes no arguments. Now, what's the implementation of this method? The implementation of this method is actually super simple. We want to delegate to a book parser, but we don't have a book parser yet because our book parser is null. So what do? We check if we have a book parser. We say if book parser, so more sloppiness, sorry, here in the instance variable I just wrote the type and not the actual variable name, so let's just actually add that. So we have a private variable of type book parser called, let's say, parser with the lowercase p equals null. So the instance variable is named parser. So we say if this dot parser is null, i.e. if we don't have one, then we need to instantiate it. Sorry, I'll just continue on the same line here in order to save space. Then we'll just say this dot parser equals a new book parser. And what do we pass that? Well, actually, the book parser requires a string. So hopefully you noticed this when I made the mistake, but I completely messed up here because of course the lazy book parser proxy needs to have a constructor. The constructor that it needs to take a string. It needs to take a string that represents this book, because whenever we then instantiate the book parser, we need to have access to that string. So now this is going to get super crammed, but let's just assume, I'll sort this out later. So I'll just say this dot book. I'll pass that to the parser. We'll solve this in a moment, but just assume that we have that book in scope. So many mess ups today. I now also notice that the sun is totally blocking this out. Let me just pull down the curtain. Much better, terribly sorry about that. So, in this method getNumPages, we've now on this first long line, we've first checked if we have a parser available, and if we don't, if it's equal to null, then we'll instantiate it. And when we instantiate it, we'll pass the book, the string representing the book. And then we'll simply delegate this method call, getNumPages, to our instance of a book parser. So we'll say return the value of invoking the method getNumPages on the parser. So return this dot parser dot getNumPages. And that's it. Now, let's actually also solve this constructor problem. I think you can probably see what the constructor would look like, but just to be exhaustive, let's actually just write that. So let me do this. Let's say dot here, and I'll continue this portion. Terribly sorry about this mess. I'll continue it up here, dot, right? So this portion should be here, right? That's where this portion should be. So what would the constructor look like? The constructor would look like this. We would say public lazy book parser proxy, and this constructor takes an argument which is of type string, and we'll call it book. And then we'll open that constructor. And then what does the constructor do? Well, the constructor simply takes this book variable that's passed in as an argument to the constructor and assigns it to an instance variable, which we didn't declare here, but let's assume that we have it. We'll say this dot book equals the book. And then I'll close the constructor. And then of course we also need to have that variable, so let's say that in this class we also have a private variable of type string and it's called book. And will default to null. So actually, to be consistent, let's just say that it's null here as well. Equals null. So again, sorry about this back and forth, but let's just review this super quickly. Here's the thing. We've got an interface called iBookParser. It says that whatever claims to be a book parser needs to have a method that returns an int and is called getNumPages. And that method takes no arguments. Then we have a concrete book parser here and we have a concrete book parser here. This thing is the real book parser and this thing is the proxy. Whenever you want to use this book parser, we are providing you with this proxy so that you can use this proxy instead because it's more performant. The proxy will delegate to this book parser, but it does so in a smart manner. It changes behavior slightly because it delays the instantiation of this concrete book parser, of this real book parser, until it knows that you actually really need that book parser. So, how does it know? Well, we have this method getNumPages, and whenever you call that method getNumPages, it checks, do I have a book parser already instantiated? If I don't, I need to instantiate it now, because when they called getNumPages, I will definitely need this underlying book parser. And if they never call that, right? If the subject, if whoever is using this proxy never calls getNumPages, then we won't ever hit this code, and we won't ever then instantiate a book parser. And thus, as we were saying before, this is the expensive parsing. This is the expensive operation. Instantiating the book parser, that's the expensive operation in this particular scenario, in this particular example. So by making sure that the instantiation of this book parser only happens in the context where we actually need it, where like when we have called one of the methods that depend on actually having a concrete book parser, we defer to that point, we've hopefully improved performance. Of course, this would require testing and you would check if it actually did improve performance, but hypothetically, it really could. And that's it. That's the whole gist of it. You put a proxy before something else, and then you call the proxy rather than calling the thing directly. And the proxy interacts with that other thing. And that's it. I hope that makes sense. If not, again, shoot something in the comments. And if you have further examples or simply want to discuss something, do also shoot that in the comments. It's always massively appreciated. Beyond that, check out the description for links to these books. They're super good if you're interested in design patterns. And also, even if you don't want to read them now, they're super good to put on your shelf because you never know when that moment will strike you when you say, wait a minute, what was actually that design pattern? And then you find the whole internet's confusing. Anyways, links are in the description. Thank you super much for watching. I hope to see you in the next one, so subscribe so that you won't miss it. In the next video, we'll talk about the differences between decorator, adapter, proxy, and facade. And then we're back to the regularly scheduled program. I don't actually know which pattern is the next, but we'll see. Subscribe to stay tuned. Again, thank you very much for watching, and I'll see you in the next one.